Find the arc length of the graph of y equals root x minus 1/3 x to the 3/2 for x is between 1 and 2. So we notice that y is given to us as a function of x. So we just go with the formula that's in terms of x. We take the derivative with respect to x, we square it, we add 1, we take the square root, and we integrate from x equals 1 to x equals 4. Those are the limits of integration a and b, respectively. Let's take it step by step. We'll first find the derivative, then we'll square it, and then we'll add 1. Rewrite the x to the half, underneath the root is x to the half, and now go take the derivative by using the power rule. Bring the half down, take x to the negative 1/2. Bring the 3/2 down, take x to the half. What happens? Well, these guys cancel. This negative can come in the denominator as a root. And so we're looking at 1 over 2 root x minus 1 over 2 space root x. So one has a root x in the denominator, one has a root x in the numerator, and we have taken the derivative. Great. Step 2, square it. Multiply it by itself. FOIL it out. We would get 1 over 4x, because root x and root x make up x. But then, when we multiply the outer terms, the half and the half give you a fourth. The root x from the denominator and the root x from the numerator cancel each other out. And then it's a positive times a negative, so it's a negative a fourth. The same thing's going to happen for the inner terms. Negative a fourth. And then for the last terms, the root x and root x give you x. Negative a fourth and negative fourth multiplied give you a negative half, and negative a half multiplied give you a positive 1/4. Okay, great. The outer and the inner should combine. This time they're going to give you a negative a half. We have squared the derivative. Last step is to add 1. So we'll add 1 to both sides. 1 to the left, 1 to the right. It'll interact with that negative half by flipping it and making it a positive 1/2. The other terms will stay exactly the same. And that's step 1. Find the derivative, square it, and add 1. Step 2, simplify before taking the square root. If possible, you won't always be able to do this, but if possible, represent what you have as a perfect square. Now, from the slide earlier, we saw that when we squared out 1 over 2 root x minus 1 over 2 times root x, we have a negative a half from the middle terms combining. Well, if we had put a plus in between them, we would have a positive half. And that's where we're at right now with a positive half. The outer terms would stay the same, and your negative 1/4 and negative 1/4 would combine to give you this negative half, which used to do that. Now, if we just put it with a plus sign, it'd be positive fourth and positive fourth combining to give you a positive 1/2. It's very important you recognize that, because that's going to help us to be able to integrate this by our ability to be able to write this as a perfect square. So that when it comes time to take the square root of both sides, the perfect square operation will cancel out the square root operation, and we end up with just what's underneath. And that's what we integrate. The starting x was x equals 1. The ending x was x equals 4. And we need to integrate this. These roots give us no use unless we write them as the fractional powers. So we have 1/2 x to the negative 1/2 and 1/2 x to the positive 1/2. These guys are added together. Now let's go to the final slide and execute the integration. We need to find the antiderivative. We have x to the positive 1/2 times 2. And then we have x to the 3/2 times 2/3. 2's cancel out. you end up with the root of x plus 1/3 x to the 3/2 as your antiderivative. And then you just apply the 4. Plug a 4 in, and you get the root of 4, which is 2. 4 to the 3/2, which is 8. Put a 1 in, the root of 1, and then 1/3, because 1 and 3/2 is 1. Almost done. We need to, so 4 to the 3/2 is 4 to the 1/2, then cubed, or 2 cubed. It's 8. 2 plus 8/3 minus these two together give you 4/3. Okay, we can put these together and call it 4/3, or we can just put everything over 3, and we get 6 plus 8, 14 of them. Take away 4 of them. Final answer, 10/3. That's how long the curve is from x equals 1 to x equals 4.